Yes, dear students, in this video I am going to discuss with you conical pendulum. Conical pendulum. Actually, when a heavy point mass tied to a string, which is light string, and is sensitive, rotates on a circular path about its center in horizontal circle. In horizontal circle, it is called conical pendulum. A heavy point mass tied to one end of string, which other end connected to rigid support. When rotate along circular path about center O, as shown in this figure, then the pendulum is called conical pendulum. Actually, this topic is an application of centripetal force. So we will derive the expression for time period. Let the height of center of circular path from the rigid support be h, length of the string be L, and mass be m, radius of circular path be r. तो इसको हम क्या लेके चलेंगे? Now why it is called conical pendulum? Sorry. Here when rotate the string connected to the mass m connected to this will describe a cone and will not move in a plane like जैसे ना पेंडुलम से ये तो एक प्लेन में ओसिलेट हो रहा है और अगर ये यूं हो तो इट में कोन, तो दैट इज व्हाई इट इज कॉल्ड conical pendulum. Now let m mass attached to string of length L describes the circular path of radius r. Here it is understand this angle 90 degrees circular path, the height h. So here L is equal to r equal to, we can write L sin theta, because ये थीटा हो गया, ये रेडियस तो परपेंडिकुलर have to is L, so it is L sin theta. Now when the bob revolves, there will be tension in the string, and you know, to move on circular path, body needs centripetal force. So question arises here, from where we get centripetal force? If we resolve tension T into rectangular component, they are shown here, T cos theta and T sin theta. T cos theta exactly at vertically up and weight of both this mass mg acting downward. So here T cos theta balance the weight mg. T cos theta is equal to mg. While T sin theta, I told you to move circular path, body needs centripetal force. So from here the body will get centripetal force, and I have told you in the last video that centripetal force is the force required to change the direction only. That is required. So who will provide centripetal force? T sin theta. So T sin theta is equal to mv square by r. equation 1 and 2. I think it is very clear. This mass m is revolving on circular path tied to this string of length L, and the vertical height of the circular plane from point BH. Here our radius will be, I told you, L sin theta. Now if we divide 2 by 1, we get tan theta. लिख सकते हैं आप, dividing equation 2 by 1, we get tan theta is equal to v square upon rg. It is very interesting topic, but generally we teacher in the class or school adhere to our discussion entirely on syllabus. But in competitive exam, questions come based on the syllabus also. This topic is application of centripetal force, nothing else. तो उसको समझाने के लिए वो क्वेश्चन पूछ लेते हैं. आई सी इन बोर्ड दिस कॉम्पिटिटिव एग्जाम. तो tan theta here comes v square by rg, but from this figure tan theta क्या होगा? मैंने कहा ये कि 90 डिग्री है, ये थीटा है, तो ये बेस, ये बेस है परपेंडिकुलर. tan theta इक्वल टू r अपॉन h है भाई. tan theta इक्वल टू r अपॉन h, tan theta इक्वल टू बेस अपॉन परपेंडिकुलर बेस. ये परपेंडिकुलर, ये बेस, and hence we can write r upon h equal to v square by rg. You know, velocity, ये velocity tangential होगी, and v equal to r omega, where omega equal to 2 pi upon capital T, and called angular velocity of circular path. So if I put it here, we get r upon h is equal to r square omega square upon rg. All r can get cancelled. So here what do we get? Omega square h is equal to g. What is here g? What is small g? Acceleration due to gravity, which remain constant at a given place, whose value we take 9.8. So from here we get कि omega is equal to under root g upon h. है भाई, omega is equal to under root g by h, but omega is equal to 2 pi upon t also. Under root g upon h. What is this capital T here? Time period. T is the time period. तो क्या होता है? What is time period? That is equal to time taking. Time taking by body to complete a circle. From here you get t equal to 2 pi under root h upon g. H upon g. But h equal to L cos theta also. This is theta, this is 90, ये perpendicular base upon I have to be cos theta. So h equal to L cos theta. So t is equal to क्या होगा भाई? 2 pi under root L cos theta upon G. Equation 3. So this equation shows that time period depend on theta. So if time period decreases, means particle move faster. So theta decreases. Theta decreases if t decreases. Then cos theta decreases. But cos theta here decrease as value of theta is from 0 to 90. So here theta cannot be 90 degrees. Why? If theta become 90, then time period 0. Or time period 0. Tani. So this angle theta is a very important discussion here. If time period 0 नहीं होता, लेकिन अगर थीटा मैंने कहा ना थीटा 90 नहीं हो सकता, थीटा कैन नेवर बी 90 डिग्री है, मीन्स अगर थीटा 90 तो इट विल मूव ऑन सर्कुलर पाथ हियर, but this does not happen. It never will move around point A because time period then will become 0 according to this formula. I think it has become clear to you all. Now if theta tends to 0, this approximation, that cos theta equal to 1 होता है, but this happens to up to 10 degree, 10 to 15 degree. यानी कि theta is less than 10 degree, 0 to 10. Then from this equation, t equal to 2 pi L upon G. And this is the time period of simple pendulum, which you have heard in class 10, and we will learn class 11 later on while studying simple arm motion. So that way, for theta tending to 0, there is no difference in the time period of simple pendulum and conical pendulum. Whatever is the time period of simple pendulum, same is that of simple pendulum and conical pendulum. When theta is small, if you see your pendulum in a lab, initially that moves circular path and later on become on a straight line, because this time period t equal to 2 pi under root L upon G is derived for pendulum when we assume that it oscillates to and fro about a fixed point in a straight line, while we have derived it assuming it is moving on circular path. So in lab, students are asked that pendulum amplitude should be such that the angle theta does not exceed 10 degree. इस small angle के लिए true है. Formula for time period. So this was something about conical pendulum. Once I have seen the question based on this pendulum in entrance test for Roorkee entrance test. At that time IIT and Roorkee were holding test separately. So actually in our syllabus centripetal force is there. So it is an application of centripetal force. You cannot say it is beyond syllabus. Although the testing agencies are asked by the Supreme Court to set the syllabus, to set the paper within the syllabus. So it is within syllabus. Don't think that it is beyond syllabus. For every competitive exam, this topic may be asked. Thank you. मिलते हैं.